555 timer operation.
Crazy engineers.
Introduction to 555 timer. The IC 555 timer was invented by Signetic Corporation in 1971, and it was termed as SE or NE 555 timer. Generally, it is a monolithic timing circuit that gives precise and highly stable delays of time or oscillation. These types of ICs are very cheap and reliable in cost when we compared with the operational amplifier applications. These ICs are used as an astable and monostable multivibrators in digital logic probes, DC to DC converters, tachometers, analog frequency meters, voltage regulators, and measurement devices. The IC 555 is used in the temperature ranges from -55 degrees Celsius to 125 degrees Celsius. 555 timer pin diagram. The 555 timer IC got its name from the 35 kilo ohm resistors that are used in its voltage divider network. This IC is useful for generating accurate time delays and oscillations. The 555 timer IC is an 8-pin mini dual inline package DIP. This 555 timer IC can be operated with a DC supply of +5 volt to +18 volt. It is mainly useful for generating non-sinusoidal waveforms like square, ramp, pulse, etc. 555 timer pin description is shown below. Inside the 555 timer IC. Here's the internal schematics of 555 timer, which consists of 25 transistors, 2 diodes and 15 resistors. 555 timer functional block diagram. A 555 timer has a resistive network formed by 3 equal resistors, R. It is due to these 3 5 kilo ohm resistors, the IC bears its name as 555 timer. These are arranged in voltage divider configuration and provide the voltage values of 2/3 VCC and 1/3 VCC. 2 comparators. Comparator 1 compares threshold voltage with a reference voltage plus 2/3 VCC volts. Comparator 2 compares the trigger voltage with a reference voltage plus 1/3 VCC volts. 2 transistors. These are associated with discharge and reset operations of the device. One is our flip-flop. This flip-flop will be either set or reset depending on the output from the comparators. An inverter is used to obtain the output from the device by complementing the flip-flop's Q-bar output. Voltage divider network. The voltage divider network consists of a 3 5 kilo ohm resistors that are connected in series between the supply voltage, VCC and ground. This network provides a voltage of 1/3 VCC between a point and ground, if there exists only one 5 kilo ohm resistor. Similarly, it provides a voltage of 2/3 VCC between a point and ground, if there exists 2 5 kilo ohm resistors. The supply voltage is applied to VCC with respect to ground. So, this voltage divider network provides 2/3 VCC at the non-inverting terminal of the upper comparator, UC, and 1/3 VCC at the inverting terminal of the lower comparator, LC. Comparator. We know that the comparator compares the two inputs that are applied to it and produces an output. If the voltage present at the non-inverting terminal is greater than the inverting terminal, then the output of comparator will be plus Vsat. This can be considered as logic high 1. If the voltage present at the non-inverting terminal is less than or equal to the inverting terminal, then the output of comparator will be minus Vsat. This can be considered as logic low 0. The comparator reference voltages are fixed at 2/3 VCC for upper comparator and 1/3 VCC for lower comparator. The positive going pulse applied at the threshold terminal, and when the voltage at threshold terminal exceeds 2/3 VCC, the output of the upper comparator changes its state. This change of state resets the flip-flop, whose output goes high. the negative going pulse, applied at the trigger terminal, and, when the voltage at trigger terminal exceeds 1/3 VCC, the output of the lower comparator changes its state. This change of state sets the flip-flop, whose output goes low. SR flip-flop. The truth table of SR flip-flop is shown below. The outputs of lower comparator, LC, and upper comparator, UC, are applied as inputs of SR flip-flop as shown in the functional block diagram of 555 timer IC. When the flip-flop is reset, the output is low at the output terminal, and when the flip-flop is set, the output is high at the output terminal, as per the truth table. Transistors. The functional diagram of a 555 timer IC consists of one NPN transistor Q1 and one PNP transistor Q2. The transistor Q1 acts as a discharge transistor. When the output is high, the transistor Q1 is reverse biased to off condition, which makes the discharge terminal, pin 7, open. When the output is low, the transistor Q1 is forward biased to on condition. Then the discharge terminal, pin 7, is connected to ground. A capacitor is connected to discharge terminal and ground. When the transistor Q1 is turned on, the capacitor discharges through Q1. The transistor Q2 acts as a buffer. Transistor Q2 isolates the reset terminal from flip-flop and transistor Q1. Inverter. The inverter used in the functional diagram of a 555 timer IC not only performs the inverting action but also amplifies the power level. Special features. Low turn-off time. Maximum operating frequency greater than 500 kHz. High output current, 200 mA. Adjustable duty cycle. TTL compatible temperature stability. Timing from microseconds to hours, operates in both monostable and astable modes. Applications. Sequential timing, pulse generation, precision timing, time delay generation, linear ramp generator, pulse width modulation, pulse position modulation.
Thank you for subscribing to Crazy Engineers.